Now, in the movie, you said in quantum theory you can also go backwards in time. So I asked David Albert about that, and he said, well, no, quantum theory doesn't say you can go backwards in time. He says the equations of physics have time reversal symmetry, but you can't really go backwards in time quantum, which seems to be different than what you said. So could you elucidate on...
Yeah, we actually talked about it at the cocktail party last night.
Oh, you did?
And we agreed that there may not be anything, such a thing as time, except in consciousness. In other words, outside of consciousness, there may not be a flow of time. Time may exist, but not in terms of flowing in a direction. There may be only this now, this individual now, and then maybe another now and another now and another now, and we connect them through memory and so forth. But outside of consciousness, there may not be a flow of time. So the laws of physics allow time symmetry, reversibility, and so forth. The way I think of it is that consciousness gives our classical world a flow of time, but in the quantum world, time doesn't flow, and therefore we can, from our perspective in the classical world, or at the edge between the classical world and the quantum world, time seems to be going backwards. Now, for example, in the classical, well, in the quantum, in the historical EPR experiments, in which you have two particles that are in superposition and entangled, and you send one over this way and one over this way, and make a measurement here, this one instantaneously reduces to the complementary situation. So there's some kind of instantaneous communication, which would be faster than the speed of light and prevented by relativity. So what a number of people have suggested, Ben Schumacher, Roger Penrose, and others, that the information here goes backwards in quantum, the quantum information goes backwards in time to when the particles were unified, and then forward in time to bring the quantum information. Now, going backwards in time is a problem in terms of causal paradox, because if you could go backwards in time, you could go back and kill your grandfather and you wouldn't be born. But quantum information doesn't really convey that sort of signal. It's more of a correlation. It's more of a qualifying modification of classical information. So I think it plays a role in consciousness in terms of modifying information and making it conscious. You know, there are many things that the brain does that we do that the perceptions seem to take longer to occur in the brain, and we've already responded to them. Rapid conversation. You say something, and before my brain has actually processed and come to conscious realization of what you said, I've already responded. Hitting a baseball at 90 miles an hour is physically impossible according to the perception time in the brain, and yet people do it. There are many illusions that occur where the brain seems to know in advance what will happen. Ben Libet's famous experiments also suggested that subconscious information goes backwards in time. So quantum information, when I say quantum information goes backwards in time, you could say equivalently that in the quantum world there is no such thing as the flow of time, and that in the classical world we have the illusion of a flow of time due to consciousness ratcheting forward and with a sequence of nows that follow one another.
Now, if I was just someone on the street and I heard that, they'd say, well, wait a minute, you say time doesn't really, it's only consciousness. I mean, that's the old question, if the tree fell, would someone hear it? So if someone dropped a basketball on the basketball court and no one was there was no consciousness involved, would the ball still fall? Because the ball seems to fall through different states as time moves forward.
Right. Yes, I think so. And but that would mean that there's a sequence of nows, but maybe only when somebody becomes aware of it. It depends on your interpretation of quantum mechanics. If you are a Copenhagen person, you would say, no, there's a quantum superposition of multiple possibilities, and the ball doesn't fall until somebody observes the ball falling. If you are a decoherence person, you could say, yes, it falls because it collapses to one possibility. And if you are an objective reduction person, you would say also that it falls because it has reached the threshold for collapse, or it has decohered. So, yes, I would say that it falls. So that's a good question. I stand by what I said, that consciousness gives because the other way to say it is that the ball could also go backwards. And against well, that doesn't really make sense. So I don't know.
Okay, because it's a real head scratcher. What was the?
Excuse me. Well, let me just make one more comment because I didn't really handle it very well. The second law of thermodynamics says that things unwind and move forward. So that gives an arrow of time. But at the quantum world, in the micro world, the second law of thermodynamics doesn't seem to hold, and things can go backwards or be timeless. So in the quantum world, there's no flow of time, whereas in the classical world, there is. I think that's probably a better explanation.
So if there's no flow of time, are there any, what experimental data is out there that seems to suggest that time is funky down at the quantum level?
Well, even in the classical world, Wheeler and Feynman showed that time was symmetrical, and that electromagnetic information goes forwards and backwards. But the backwards information is only perceived by what they called the coherent absorber. And what a coherent absorber they didn't explain, but Dick Bierman, a physicist in the Netherlands, has suggested that consciousness is such a coherent absorber which is capable of receiving backward-flowing information. So only consciousness receives this backward information.
So then, of course, the question now remains, what is consciousness?
Yeah. Well, I define consciousness according to Penrose's view. It's a particular type of self-collapse of the wave function. Now, as you know, things can be in superposition of multiple possible states or locations. That's quantum superposition, and that's the natural state in the quantum world. Now, we don't see that in our classical world. Why not? Well, one explanation is that conscious observation causes collapse. That's the Copenhagen interpretation. Another is that every superposition branches off and forms a new universe, the multiple worlds hypothesis. Another is that interaction of superposition with the environment causes decoherence. And the fourth possibility is that superpositions grow until they meet some kind of natural threshold inherent in nature, which causes them to convert from the quantum superposition state to the classical state. There are several types of these theories which are called objective reduction, an objective threshold for quantum state reduction. One is if the system grows too large, that's the Girardi-Rimini-Weber GRW theory. Another is Roger Penrose's idea that, well, first he starts with the question, what is superposition? And he says it's a separation in fundamental reality at the most basic level. So much like the multiple worlds view, the universe separates and begins to separate, but that these separations, or bubbles, if you will, in reality at the most basic level, are unstable, and after a while will collapse to one or the other. And that this type of collapse, this type of objective reduction that occurs due to this instability in the separation of the universe is consciousness. And it can only happen in very special circumstances because you need a system that's isolated from the environment, so it has to be protected, so it doesn't decohere, and it has to be large enough to reach this threshold. The threshold is given by, it's inversely related to the size of the superposition. So something very small, like an electron superposition, if protected from decoherence, would take 10 million years to reach threshold, and then it would have a very dull, tiny moment of consciousness. Something very large will reach threshold quickly. And in the brain, we think that quantum computations occur which reach threshold roughly at 25 milliseconds. So 40 times a second, we have conscious moments, collapses, these self-collapses, in which the superpositions collapse to the classical world. And it's a process occurring at the most basic fundamental level of the universe, at the Planck scale, basically, connected to the brain by quantum computations occurring in our brains.
So it almost sounds like you're saying that consciousness arises out of having a brain.
Well, not necessarily. Well, it helps, but any superposition that reaches threshold for self-collapse would have this. And it could happen in a neutron star, which have very large superpositions, but there wouldn't be any information involved. It could have happened at the early universe during the Big Bang, for example, when, for example, some people think that the universe was in superposition during the Big Bang, during the period of inflation, and reached a critical threshold right at the end of inflation, and then collapsed to one universe. And this is a theory put forth by an Italian astrophysicist named Paolo Zisi, who calculated that the period of inflation ended just when the threshold for Penrose objective reduction would have been reached, and that the universe literally had a conscious moment during the Big Bang. And this has been called the Big Wow theory. And so the entire universe would have had a conscious moment at its very birth, and that our consciousness may be related to that initial conscious moment.
So does consciousness exist outside of the body then?
I would say that proto-consciousness exists everywhere at the Planck scale. Proto-consciousness is basically anything that's in superposition. Anything that's in superposition can become conscious if it avoids decoherence and is allowed to evolve long enough to reach this threshold for self-collapse. Now, if it's a very large superposition, and the larger it is, the harder it is to isolate from the environment to avoid decoherence, the faster it will reach threshold. So an electron, as I said, could reach threshold if it were protected for 10 million years. Something larger, like nanograms of protein in our brain, can reach threshold in 25 milliseconds, and we can have roughly 40 conscious events per second or higher.
So still, if you're, I'm thinking there's all those studies done of out-of-the-body experiences, near-death experiences.
Right.
You'd say in a near-death experience, people, sometimes I saw that documentary you were in where, the persons, they take the brain and they freeze it and it stops and nothing's happening there and the person's up and having all these experiences. Right. How would that fit in with what you're saying? Because it seems like that the consciousness is working independent of the meat.
Right, exactly. Well, what I think happens in near-death experiences, and maybe in death also, is that prior to that, while the brain's functioning, metabolism is occurring, quantum coherence and quantum computation is being driven by the metabolism. When that ends, when the blood stops flowing, the quantum information leaks out to the universe at large because it exists in the Planck scale. It exists at the most fundamental level. Even during normal consciousness, it's occurring at the most basic level of the universe. But the Planck scale, the fundamental level, between our ears in the brain. But when the coherence is lost, it kind of leaks out to the universe at large. But it doesn't dissipate entirely because of entanglement, and plus the universe is probably holographic, so it remains with a phase relationship and can persist, at least at a subconscious, dreamlike state outside the body.
So let's talk about creating your reality.
Yeah.
I mean, we've gotten a lot of, grief on that. Some people say, well, that's not really true. Quantum mechanics doesn't suggest that, blah, blah, blah. They go on and on. So what's your take on all that create your reality stuff?
Well, the extreme view would be idealism. Bishop Berkeley and the Hindu approach, which says that consciousness is all there is. And that all there is my consciousness. I'm creating you and the camera and the world around me. And all there is me, and that runs into the problem of solipsism because you probably have the same view, but somehow our realities get along well enough for us to be friends and interact with each other. So, but that is a view that's impossible to refute because I can't really prove that you are out there in reality and have your own consciousness, and you can't prove that I'm conscious. So, idealism, both from the Western standpoint from what Bishop Berkeley said in the Hindu tradition, is one possibility. Another possibility, the Copenhagen interpretation says we create reality by an observation collapses the wave function. The problem with that is it doesn't say what observation is. It doesn't say what consciousness is. Why is our brain different from a measuring device or anything else? And it kind of puts consciousness outside science. So my view is somewhere in the middle with the Penrose objective reduction, where you have a superposition which reaches threshold and self-collapses and chooses a reality at that point of a number. It's kind of a multiple choice. It's not like starting from scratch anything you want. It's a multiple choice of multiple possibilities for each specific collapse. But the beauty is, this is one of Roger's great contributions, I think, is that he said the Platonic information embedded in the fundamental level of the universe helps to choose or influences which choice is made. And this only occurs, however you want to put it, the quantum information embedded at the Planck scale will influence your decision one way or the other for the good, generally. Self to be influenced by what you want to call instinct or intuition or your higher power, or the way of the Tao, or may the force be with you, however you want to put it, the quantum information embedded at the Planck scale will influence your decision one way or the other for the good, generally. So it's kind of a way of bringing in some kind of spiritual divine guidance, if you will. So what is the difference between the classical physics and quantum physics? The universe is very strange. There seem to be two sets of laws that govern the universe. In our everyday classical world, meaning at roughly our size and time scales, things are described by Newton's laws of motion, set down hundreds and hundreds of years ago. And they work very well for billiard balls and cannonballs and gravity, and then we have Maxwell's equations for electromagnetics, and that's all classical, and that works beautifully. However, when we get down to a small scale, when we get down to, say, the level of atoms, and the actual threshold or cutoff is unclear. It can be actually larger in some cases. A different set of laws take over. These are the quantum laws, quantum theory, quantum mechanics. And at that level, particles may be in multiple places at the same time. They may behave as waves smeared out spatially and temporally. They may be interconnected over great distances. They may be unified into one quantum state, into one state, governed by one wave function. And the borderline, the threshold, this curtain between the quantum world and the classical world is really mysterious. It's called sometimes the collapse of the wave function, because in the quantum world, everything is in superposition of multiple possibilities, and in the classical world, these multiple possibilities seem to collapse to particular definite choices. So everything is in one particular place. This collapse, by the way, is utilized in quantum computation. Classical computers, for example, have bits where information is represented in a binary fashion as either 1 or 0. In a quantum computer, superposition is utilized, and information can be represented in superposition of both 1 and 0 at the same time. These are called quantum bits or qubits. So if you have a system of qubits in superposition, they communicate with each other non-locally. They don't even have to be next to each other. Non-locally, as long as they're isolated in one system. And while they communicate, they process information according to the Schrödinger equation very efficiently. And this goes on for a while and performs computation. And ultimately, the system collapses, and each qubit of 1 and 0 chooses either 1 or 0. And that is the output or the result of the quantum computation.
So how do these, you said they communicate, these two things. How do they communicate if one's there and one's here?
How do things communicate non-locally in the quantum world? Well, that's the big question. It's been Einstein, Podolsky, and Rosen tried to more or less disprove this by coming up with a thought experiment. But ultimately, their thought experiment turned out to be true. They said that if two components of a quantum system, for example, two photons that were coupled with the polarization, opposite polarizations, or two electrons that were coupled with spin up and spin down, were in superposition. So, for example, the two electrons were both spin up and spin down. If they were separated, and one was sent down a wire 100 miles this way, and one was sent down another wire 100 miles this way, when they reached their destination, they would still both be in superposition of up and down. But if one is measured, the other one should instantaneously collapse to the opposite complementary spin. Sure enough, this turns out to be the case. This was first shown in the 1950s, and more recently has been shown hundreds of times in the laboratory. If you have a pair of coupled electrons in superposition of both up and down, send one down a wire or a cable to one village, another down a wire or cable to another village, make a measurement on one, the other one instantaneously takes the opposite spin. Instantaneously, which means any information between the two must travel faster than the speed of light, which is thought to be impossible in classical physics. How does this occur? Nobody knows for sure. But one possibility that Roger Penrose suggested is that the information actually from this one goes backwards in time to when they were together, then out the other limb to the other one. And this is used in a system called quantum cryptography, where quantum theory is used to encode information that is basically uncrackable. Another aspect of quantum computing that's very efficient is factoring large numbers into their primes, which is also used in codes and cryptography, so that if and when someone builds a useful, efficient, reliable quantum computer, all military and banking codes will be obsolete. Therefore, governments and industry are pouring huge amounts of money into quantum computation, and tremendous progress has been made. And furthermore, when quantum information technology comes along, when we do have quantum computers, people are going to be more likely to accept the fact that we have quantum computers in our brain, because we certainly wouldn't want something on our desktop that's better than what we have between our ears.
Okay, how does non-locality, could you use that to explain things like ESP and near-death experiences and all that kind of stuff?
Can you use non?
A little hot and dry.
I was going to say entanglement, but you said non-locality.
Well, you could say entanglement. Either one. It's
okay. Can you use quantum non-locality and entanglement to explain things like ESP, near-death experiences, and so forth? I believe you can. I think entanglement and collapse in one system inducing collapse in another is exactly what happens in parapsychological phenomena. And it's also true that time can go backwards, so that they don't even have to be simultaneously. One can occur before or after the other. And near-death experiences, particularly when patients report leaving their body and floating above them, their bodies, watching themselves being worked on, and then return to their body, could be due to the fact that consciousness is ultimately a process in fundamental space-time geometry. And when the coherence driving the system stops due to the metabolic insult to the brain, the information is still in fundamental space-time geometry, which is everywhere. So it would tend to start to dissipate. However, due to quantum entanglement, would tend to stay somewhat localized and float above, maybe go out into the waiting room and visit with relatives, which has been reported in near-death experiences. But then when the body is resuscitated, revived, and the metabolic drive in the brain resumes, the information returns to its host, the brain.
Well, do you think many people say that they believe in reincarnation and remember, experience past lives and all this kind of stuff? Could this possibly be a mechanism whereby the universe kind of remembers who you are and what your tendencies are, so that the reincarnation process? I mean, could this fundamental information be the bookkeeping of reincarnation?
Could the same sort of thing happen in death and in reincarnation? Yeah, I believe it can. I think the same sort of thing I described, where the consciousness leaves the body and returns when the body is resuscitated. If the patient dies, then the quantum information or consciousness, or proto-consciousness, if you will, isn't destroyed and may dissipate or may sort of hang together due to quantum entanglement to exist, I should say, in some sort of afterlife situation, and possibly return to some other body, being reborn subsequently over time, which would account for something like reincarnation. So I think it's possible, if we assume that consciousness, or at least proto-consciousness, meaning something like our subconscious, exists at the fundamental level as a process at the fundamental level of space-time geometry, because that's everywhere and always was and always will be.